Let's start with, there are not many of us who are of a certain vintage. Polite way to say old fossil, or something starting with a F. Fill in. For those men in the space, for those men in the space business who are also of a certain vintage, you remember why. Back in the day, there were no women in the space business. Sure, there were secretaries and technical aides, but there were no women at the drafting tables. Remember those? No women handling boxes of computer cards. Remember those? No women in the smoke-filled rooms. Oh, are we so glad those are gone. No female voices on the telephone conferences, no women in mission control. There were a few exceptions. Examples were Yvonne Brill in satellites and Barbara, also known as Bobby Johnson, on the Apollo program, and and amazing Grace Hopper in computers. But they were very, very rare. I had the privilege to know several of those. I actually worked for Bobby Johnson. When I was earning my first aeronautics and astronautics degree between 1969 and 1973, engineering enrollment of women at the University of Washington, where I was attending, passed 1%. Okay? So what that tells you, it's not that long ago when there really were no or almost no women, an insignificant percentage of women in the space industry. And I certainly experienced that myself. I was the only woman in most of my classes in engineering at the University of Washington. I was the only woman in all of my master's degree classes. When I went to work on the space shuttle program at Rockwell in Downey, California, just a few miles up the road here in 1974, I was the first woman engineer most of my male colleagues had ever met. The guys literally didn't know how to behave around the few of us who were in and joining the industry in the 1970s. And for instance, what do you do when arriving at a door or exiting an elevator at the same time as a woman? Really, the rules all had to be written. Was it necessary to remove cuss words from the normal language of the day? And there was a lot of cussing in those days, especially when things were not going well. I actually remember being offended when a manager who was known for just cussing all the time, when I arrived in a meeting and he didn't cuss at all, because that meant he had changed his behavior because of me, and that was wrong. So I knew I was accepted when he started cussing a blue streak. You know, fortunately, I didn't get all red. So we women also had to establish new standards of how to dress because there were really no guidelines for how women engineers would appear versus the secretaries and the technical aides. It's different now, and it's a great thing. The Society of Women Engineers was started in 1950. Its conferences in the 1970s barely included 200 attendees who could fit in one room. Now, those conferences for Society of Women Engineers, obviously all engineering disciplines, not just aeronautics, but now those Society of Women Engineers conferences attract 5,000 to 6,000 engineers, women engineers, and there are only a few conference centers in the country that can accommodate them. Very different from back in the 1970s. Young women entering the space business now have the same opportunities as young men. I wouldn't say that for some of us old fossils, but anyway. Women are at the CAD terminals and the analysis workstations. They're running meetings. They're serving as flight directors. They're serving as astronauts and corporate executives. In recent months, I don't recall the exact months, but in recent months, for the first time ever, the photos on a Who's Where page of Aviation Week and Space Technology, which is the industry magazine, showed only women. It was very much noticed, actually I didn't notice, but a lot of guys know, hey, the photos are only women on this page. With few exceptions, the differences between men and women are recognized now as advantages of diversity. There are subtle differences in how we think, men and women, and people with different experience in general. And throwing a variety of thinking processes at difficult problems is likely to achieve a better solution. We're learning that now in industry. If you have everybody all thinking the same way, you're going to miss something. So, Don't wonder why so few women are credited with early advances in space programs. That's in the past. We're fixing that now. Someday there can be a time when there's not a reason to recognize women differently than men in space. We aren't there yet. So let's proceed with tonight's celebration of women in space. And thank you. To get our program started tonight, I will first introduce Maria Catalina of the Astronaut Teacher Alliance and part owner of Team Stellar for the Google Lunar X Prize.
Good evening, everybody. This has been a great conference so far, and I've really always enjoyed myself when I come and get to sit around a bunch of people who are interested in really moving off this planet. Yes, you know? And about 10 years ago, I deferred a PhD program for doing astrobiology because my kids were in high school. And so for 10 years, I've taught at the middle school level, and I never could have dreamed in a million years of all the cool stuff teachers get to do if they just would look up from and out from their classrooms for a moment. I've for the Sally Ride science group, which is just right practically across the freeway over here, I've been able to do exhibits of On to Moons and Mars for the Sally Ride festivals, and then I've watched the EarthCam program really grow, and kids get so excited. You can tell the astronauts where you want the astronauts to take a picture for you. Of course, it's not quite that way, the way it works, but they get very much excited about it. And so then the GRAIL also was, of course, couldn't come a better time with all this Google Lunar X Prize stuff that's happening, you know. But what I have the great pleasure of doing tonight is to introduce the Reverend Dr. Bear Ride. And she's a Presbyterian minister and has worked with Sally for over a dozen years in preparing and working the Sally Ride science over here in the San Diego area and all over the place, in fact. And so without any further ado, Bear Ride.
We'd like to present you with this award.
Oh, why, thank you.
In honor of all you do for the space program.
Thank you very much.
You're
Thank
welcome.
you. By way of introduction, just on Monday of this past week, there was a national tribute for Sally that was sponsored by NASA and Sally Ride Science. And they put together this very cool video that I thought would probably say it better than I could. So we're going to play it for you now.
6, we go for main engine start. We have main engine start and the ignition and liftoff of STS-7 and America's first woman astronaut. And the shuttle has cleared the tower.
Earth, as astronaut Jim Lovell once reflected, is a grand oasis in the great vastness of space. It is a canvas capable of inspiring the greatest pursuits and achievements.
One of Sally's favorite pictures and her favorite views was looking across at Earth's horizon and then seeing that thin blue band and realizing that that was Earth's atmosphere, the air that we breathe, the oxygen that plants give off that we all need to stay alive, and just how thin and fragile it was, and it transformed her.
Sally Christian Ride was born in 1951 in Los Angeles, California. She was an athlete long before becoming an astronaut.
She loves sports. She actually liked team sports much more than individual sports, and even in tennis, she enjoyed playing singles, but she loved playing doubles. And that kind of collaborative mentality stuck with her in everything she did.
In high school, Sally climbed the national rankings as a tennis player, but it was the inspiration of a teacher, Dr. Elizabeth Momartz, that led her to consider a career in the sciences. Sally earned her bachelor's in physics and English at Stanford in 1973. It was in Palo Alto 4 years later, as a doctoral candidate, that Sally learned of NASA's nationwide search for the next generation of astronauts.
I still remember that Tuesday morning at 8 o'clock, opening the Stanford Daily and seeing in the lower right-hand corner of page 3 the ad that NASA had put into the Stanford and other university newspapers saying that they were looking for applications for astronauts.
She thought she was going to become a professor of physics and do research and teach and live happily ever after. And suddenly it was like, I want to be an astronaut.
Of the 8,000 candidates, NASA chose Dr. Ride as a trainee, setting the stage for her to become the first American woman in space.
We were present at her first blast-off in Florida. Seeing the power at a blast-off is very frightening. Everything shook. The first feeling was of fear. Then the feeling was she's having the time of her life.
Over the course of a decade at NASA, Dr. Ride flew 2 missions, logged over 343 hours on the Space Shuttle Challenger, and became the first astronaut to use a robotic arm in space. Her trailblazing led Gloria Steinem to note that millions of little girls are going to sit by their television sets and see that they can be astronauts, heroes, explorers, and scientists.
Even when she was at NASA, she would give talks to teachers and kids. The thing that she really noticed was that you could use space exploration as a way to excite kids about science.
Her notion was that the kids would come to see her and hear her because, she was the first American woman in space. But that's not why she was doing it. She was doing that because she knew that she could spark interest, she could encourage kids.
Determined to foster interest in science, technology, engineering, and math among American youth, Dr. Ride co-wrote 7 science books on space exploration and on exploring our planet from space. Much as she had been inspired as a student, Dr. Ride aimed to educate and engage by bringing science to life.
What we're going to do today is we're going to talk about soil.
Programs like the Sally Ride Academy, brought to you by ExxonMobil, are important because during this time and age, STEM careers, science, technology, engineering, and math are in high demand. And we're trying to prepare the young minds today to fulfill those career obligations in the future.
They teach teachers how to find ways to engage students in science, technology, engineering, and math.
I think Sally Ride Science opens the eyes of children who are studying science, but they don't know the why. Why am I studying this?
Through Sally Ride Science, Sally's beloved company, we will continue to inspire boys and girls and their teachers and parents in math and science and technology.
Sally was a champion for social change and equity in STEM education. She inspired K-12 teachers, U.S. and state governments, as well as corporate America, to improve science and math education and to support science and technical literacy for all students. From serving as a founding member of Change the Equation to engaging corporate partners such as ExxonMobil to create the Sally Ride Science Academy, Sally embodied the American can-do spirit, and she has inspired us all.
I know that through your dedication, your commitment to education, that you'll continue to encourage your students, the boys and the girls, to reach for the stars and achieve their dreams too.
Sally's legacy is one of supporting, as has already been mentioned, girls as well as boys to pursue their passion, their curiosity that is going to launch them into study and careers, perhaps in STEM. After Sally left NASA, she did become that professor of physics for a while, but really decided that she could use what notoriety she had to really spur the interests of girls, especially girls who already were interested, who already knew that there's something there, and that that engineers don't necessarily look like the stereotype, as Sally said when she entered NASA in '78, that, you know, the engineers there were, no offense, guys, but had crew cuts and short sleeve white shirts and pocket protectors. So that was quite something to break through. Speaking for Sally's family, we're so thrilled that her legacy does continue, primarily with Sally Ride Science, but also in events like this that honors not Sally, but all people, especially women, who continue to push, to study, to encourage, to inspire, and to work for equality, full equality, in science, math, technology, and engineering. I have some pictures here now. You've heard that that I am a Presbyterian minister. I am not a scientist, far from it. I miss Sally in so many different ways, but one is that whenever I had a question about anything scientific or my computer, that I could just pick up the phone and call her, and she'd say, "Oh, come on, you just do this." Fortunately, Maria is here, who in many ways has sort of stepped in for Sally in these things for me. So what I'm going to do is just show, I put together just a little, thanks Maria, a little slide show just to talk a little bit about the continuing legacy. So shortly after Sally's death, the Johnson Space Center had a tree planting ceremony for her, and the night before that time together at Johnson Space Center, all the women astronauts were invited to a private dinner. So this is the first time that those women astronauts have ever been together. And here's a picture of those that were able to come. There were about 25 of them or so, plus our immediate family. It goes from, in the lower, your left, the lower left hand, is Carolyn Huntoon, who was really the driving force to integrate the astronaut corps. So she's the grandmother of all these astronauts. In this, there is represented women from every class of astronauts, beginning from 1978, going up to astronauts who are still trainees. Remember, this is the first time they'd ever been together, and it was just amazing. We sat at a table, and after a glass of wine or two, they began to tell what it was like when they joined NASA, starting with Carolyn. And the younger astronauts, you know, some of whom, well, midway through, we hit some of the astronauts, the women who said, well, of course, I wasn't born in 1978 when the first, I wasn't born in 1983 yet. And you realize that what an eye-opener it was for them to hear the earlier stories and how wonderful it was for the earlier women to see that, that all that work that they had done had really borne fruit. So this is that group of wonderful women. Speaking of Sally's legacy, one of her favorite aspects of Sally Ride Science was the festivals, the Sally Ride Science Festivals for girls. We've done about 95 of them now, been doing it for 11 years, and it's an opportunity for somewhere around 1,000 kids and their parents and educators to come together on a Saturday for a time of fun and exploration. There's a street fair that has hands-on, experiments that the kids can do. There's a keynote. The first 25 or so festivals, Sally was the keynote speaker, and after the keynote, then the kids get to choose 2 workshops that are led by women faculty at the university, it's always at a university, or local professional women in the field of science or in STEM area. After about 25, we realized that when we went back to a specific university, they had already heard Sally. So Sally began to recruit some of her friends, and all of those, all 90-something, except for one festival, has been led by a woman astronaut. And there are about 20 or so of women astronauts who have come and taken part. That's Sally doing the keynote. Kids having fun. That was robots playing chess. This was just a couple weeks ago. It was kind of amazing. This is when Sally started bringing in friends. That's Wendy Lawrence, who's flown, I think, maybe 5 or 6 times now. Barbara Morgan, who was the first educator in space in the upper right hand. Sandy Magnus. Pam Melroy, who was a commander of both of the space shuttle, I think the second woman commander, and Cady Coleman, lower right. Another thing that Sally took on was called Toy Challenge, and that was just exposing kids, boys and girls, as teams to engineering, basic principles of engineering. They would get together, they would plan a toy, they would, and then they would build it, and then they would bring them all together and have contests. This is Kathy Sullivan, who was one of the class of '78. She was one of the judges at Toy Challenge. The company publishes a number of books, Cool Careers in Science, that are available to teachers and students. And one of Sally's passions, of course, was environmental science. EarthCam was just, Maria will talk a little bit about MoonCam, GRAIL MoonCam. Again, this is, I think, Maria, the other Maria, mentioned this. This is the opportunity for students in their classrooms to position cameras someplace on the Earth to take a picture of something specific on a camera that's either in the shuttle or the International Space Station. Very cool program. MoonCam. And the Educator Institute. And there you go. So this is a bit of the legacy of one woman in space. And if you have any questions, I'm happy to hang around afterwards. But now I would like to introduce someone who actually knows what she's talking about when she's talking about space. And that is Dr. Maria Zuber. Come on up, Maria. Maria is the principal investigator of the GRAIL mission. She's now the Vice President for Research and E.A. Griswold Professor of Geophysics at MIT. She was the first woman to chair a science department at MIT. She was the first woman to lead a NASA planetary mission, and she has been a long time collaborator, I might even say co-conspirator with Sally Ride on STEM education. So welcome with me, Maria Zuber.
Okay, so I've been asked to talk to you tonight about the GRAIL mission, which I'm very... What? Microphone. Okay? No? Hello, hello? Okay. Better? All right, great. Okay. All right. Virtually every human who has ever lived has looked up at the moon. It's something that we all share as a common experience. It really holds us together as humanity. And so it really was not a surprise that when humans first walked on the surface of the moon, that it was viewed by many as the most important technological human achievement ever. Okay. To this point, okay. At this point, the collective nations of Earth have sent over 100 spacecraft to the moon. Some have landed, brought back samples. Some have orbited and taken observations. Some crashed on the moon. Some flew right by and didn't stop. But you would think that if we had sent 100 spacecraft to observe the moon, that we would actually understand the moon very well. There are many unanswered questions about the moon, and so I'd like to talk a little bit about these and the motivation for how GRAIL fits in the picture. So, how did the moon form? We're not sure. There's only one idea that doesn't have a fatal flaw, and that is the idea that the moon formed due to the impact of a Mars-sized body into the Earth. The core of the impactor wraps itself around the Earth's core. Both the impactor and the Earth melt, material gets thrown out and accretes the moon in orbit. So what you're going to see in the next slide is a simulation done by a woman, by the way, Robin Canup of the Southwest Research Institute, showing the simulation of this Mars-sized body into Earth. So don't blink or you'll miss it here. Okay. All right, so there's a simulation of the way this process goes. This is color-coded to temperature, so red is hot, obviously. This is a smooth particle hydrodynamics calculation, including self-gravity, for those of you who are interested in such things. So you can see the Earth in the middle here, and then all this material around the Earth coalesces and accretes into the moon that we see today. So, so what we're left with after that process is something that looks like this. Okay. So there are many things about that hypothesis. We believe that the moon formed due to a large impact, but there are many details about this impact formation process that are still not understood, and I'll come back and address those later. So we're left here with a body that is very heavily cratered. Okay, in the early solar system, all of the planets formed out of a disk of dust and gas, planets accreted, and then all the stuff that was left over, okay, all the junk, impacted the surfaces of the planets in the late stage, and that's where all these impact craters come from. So Earth used to look like this, okay? But the record on Earth from this very early period of bombardment, subsequent to the formation of actually all the solid planets, isn't preserved because on Earth that record has been either subducted back into the mantle or it's been eroded or covered by sedimentation. Okay, so if you want to study early planets, the most common process that was going on that affected the early planets is the process of impacts, and that record is beautifully preserved on the moon. So while all these impacts were hitting the moon, what was going on Earth? Okay, well this is a map of Earth history, and this is today right before midnight. The first humans come into the picture 2 million years ago. The dinosaurs go extinct right here, 65 million years ago. We go all the way back, and in this period right here, this is when the largest impacts on the moon formed, and when most of the impacts on the moon formed, and the Earth. Okay, in fact, the Earth is a bigger gravitational target, so it got hit even harder than the moon did. Okay, at this period of time, when all those big impacts were hitting the Earth and the moon, the first single-celled organisms were developing on the Earth. Okay, the Earth was a terribly, and the moon were just terribly violent places. We don't know how many times life developed on Earth and got wiped out by large impacts. But we do know that early planets were a violent place. So by studying the process of impact cratering, we can gain insight into the really violent conditions that were present at the time when life emerged on Earth. Okay, so we want to study the process of impact cratering. We want to study the process of the formation of the moon, and many of these questions are unanswered, and so we decided that of the 100 or so missions that have gone to the moon, they virtually all studied the surface. And so if you've sent 100 spacecraft there and studied things and you still have questions about what's going on, then it seemed to us that the answer to the question probably wasn't on the surface, that it's probably inside the moon. So we decided to look inside. And so these are the two stars of the show here. These are our two spacecraft, and this is the way that we made the measurement of the moon's gravity field. So the two spacecraft are in a polar orbit around the moon at an average altitude of either 55 or 23 kilometers, depending on the mission time. They vary in distance between each other, that varies so that we could sample different depths below the surface of the moon. They orbit in about 2 hours, and the moon slowly turns beneath them. And so what happens here is that if we have a gravitational mass at the surface or below, the first spacecraft pulls up because it gets attracted to it and moves away from the second spacecraft, and then the second spacecraft also then gets attracted a little bit later, and it speeds up and catches up to the first guy. So we get this accordion pattern of the two spacecraft going around the moon, and it's actually very simple. We just use the distance change between the two spacecraft, which is a velocity, and we take the derivative of velocity, and that's acceleration, and gravity has units of acceleration. Okay, so all we have to do is measure distance change, and the only thing that makes this difficult is that we need to make that measurement to a few tenths of a micron per second. Okay, okay, and we beat our spec by a factor of 5. Okay, all right. Okay. Okay. All right, so here is a quick summary of the status of the mission. We launched from Cape Canaveral Air Force Base on September 10th, 2011, took a low energy trajectory to the moon, and the two spacecraft inserted into lunar orbit independently on New Year's Eve and New Year's Day. We started science data collection on March 1st of 2012. now you're going to see why I love my team as much as I do. Between the two spacecrafts, 78 maneuvers performed without incident. Neither spacecraft ever entered safe mode. We achieved our minimum success measurement requirements a year early. More than 99.99% of all the data that could have been acquired was acquired and returned to Earth. We completed our extended mission on December 14th, 2012, and impacted the moon on purpose on December 17th, and sent the memo to NASA demonstrating that we've achieved full mission success a few weeks ago. Okay. So we achieved all of the development and operational milestones on time, on spec, and we still have a substantial budget underrun. So okay. And my project manager, David Lehman, is over there and deserves much of the credit for this. Okay. All right, so why go to the moon in 3 months when the Apollo astronauts went there in 3 days? Okay, so if you go to the moon in 3 days, you go barreling towards the moon, and then you've got to slow down so that the moon's gravity can capture the spacecraft into orbit. We had, you saw those two spacecraft, they're about the size of an apartment-sized washer and dryer, and they were adapted from a successful classified mission that Lockheed Martin Astronautics had accomplished. We did not want to redesign the spacecraft, including the fuel tanks, too drastically. So what we did is sent the two spacecraft out to the L1 Lagrange point so that we could just nudge them out, and the Lagrange point is the place where gravity vanishes between the Earth-Moon system and the sun. So it's essentially like a buoy. And so we were able to come back and then enter orbit. We only had to lose 190 or so meters per second of velocity to get captured into lunar orbit. Okay. In addition to that, no matter what day of our launch window we launched, you get to the moon on the same day, so you could completely decouple cruise operations from orbital operations, which allowed a great simplification. It also allowed the spacecraft to degas, and the two orbit insertions were critical maneuvers. By going on this trajectory, we were able to make those orbit insertions 25 hours apart so that we weren't doing two mission critical maneuvers on the same day. Okay, so that's why we wanted to do that. Okay, this is a map. Here, the near side of the moon, as seen from Earth, is in the middle of this, and the far side that we'd never see from Earth is on either side. And this is the minimum altitude of mapping that the two GRAIL spacecraft achieved. So we wanted to get the highest spatial resolution map that we could get. So it really helped that we beat our measurement spec by as much as we did, but nothing beats flying low. And so this is altitude above the lunar surface in kilometers, and everywhere on this diagram that is dark blue correspond to altitudes where the two spacecraft were flying at the height of a commercial airliner above the Earth or equivalent. So we were always, during the extended mission when we were flying at our lowest, we were always within about a week of crashing on the moon. So, so the orbital operations were very complex. Okay, but we did improve our knowledge of the gravity field of the moon, and I'm going to show you this graphically in terms of pictures rather than in terms of power spectrum, which is what we usually use. So now, in contrast to that last diagram, this is the pre-GRAIL gravity field of the moon. And here the far side that we don't see from Earth is in the middle, and that was never sampled very well. The near side of the moon is on either side. This is gravitational acceleration in milligals, where a gal is a centimeter per second squared. The big red bullseyes are mass excesses. These are the mascons that tugged around the first lunar orbiters that were sent up there to look for landing sites for the Apollo astronauts. And so you can see the stripiness here in the far side where we don't have direct tracking of the moon. And I'm going to show you here the first gravity field that we made from GRAIL. And so you can see here that we made a significant improvement. This map here has a spatial resolution of about 25 kilometers. The current gravity field that we have now has a spatial resolution of 5 kilometers, and there's still unmodeled signal in it. But I didn't even put that there because the resolution of this screen couldn't do it justice. Okay, all right. Okay. All right, so this is just a little globe rotating, showing you see here the very high resolution. We basically resolve every crater on the moon larger than about 7 or 8 kilometers now. And so you see all of this small wavelength structure that actually looks a lot like the topography. And in fact, at short wavelengths, more than 99% of the gravity field correlates with topography. And, but if we want to study the inside of the moon, what we want to do is subtract away all of the gravitational signal that's associated with topography so we can see what's inside. And if we do this here, here we've done that, and you can see now how smooth the gravity is. So you're seeing only 1% of the gravity field here that is due to at short wavelengths. You can see here the mascons that we have a paper coming out in Science on May 30th where we have determined why these mascons exist. It's been a 40-year-old mystery. It's embargoed, so I can't tell you what the answer is right now. But read Science on May 30th, okay? So once we have this information on the inside of the moon, we can do things like calculate what the density of the crust is. So we've done this here. Here, the white areas are areas that we did not model because those are places where there are large lava flows on the surface. And these density numbers probably don't mean a lot to you, but the average density of the lunar crust turns out to be this number, 2516 kilograms per meter cubed. And why this is important is because prior to GRAIL, we thought the density of the lunar crust was about 2,700 or 2,800 kilograms per meter cubed. And we thought that because we brought back rocks from the moon and measured their densities, and it turns out that the average density of the moon is a lot less than that. And so the reason is because the moon is all fractured up. And you can see down here, these lower numbers are actually around all the impact basins. So we can actually map out on the moon how the process of impact cratering breaks up material and ejects it and throws it around. So this helps us understand the energy budget that is associated with impact cratering. And then taking those Apollo samples, which we still analyze today and are still bringing great value to us scientifically, and knowing the density of those samples, and then knowing the density that we measured from GRAIL, we can calculate what the porosity of the rocks is. And the average porosity of rocks on the lunar surface is, well, it's 13.5%. It varies a lot, but the greatest porosity and therefore the greatest fracturing, again, is in association with all the large impacts. So we're in there and we're able to now assess that and really understand. So in an impact, you dump a huge amount of energy into an area on the surface, and some of it goes into pushing the surface down, some of it goes into ejecting material, melting, vaporization, moonquakes, and if it's a really big one, moving the moon on its axis. And so in order to understand that process, we have to understand how all the energy is partitioned, okay? And that's what we're trying to do. So the other thing that we can do is actually calculate the thickness and therefore the volume of the moon's crust, which we have done. We finally have a value, a global value, that is consistent with the values that were measured in point areas from the Apollo seismometers. So we've gone more than 40 years without having a global model of the volume of the lunar crust that was consistent with surface observations. We now have that. And by knowing what the volume of the crust is, we know the elements that make up the crust. And it turns out that the elemental composition is one of the things that you really need to know to test models of the formation of the Earth-Moon system. So one of the important elements in this is aluminum, okay? And so geochemists who study the moon have for many years two contrasting views. And this is plotted here as just the number of papers people have written, and then the value of, so the moon is either similar in aluminum to the Earth, or the moon has about 1.5 to 2 times the aluminum in the Earth. And the simulation that I showed you for the formation of the Earth-Moon system very early on assumed that the moon has a lot more aluminum than the Earth does, okay? However, wrong, okay. And actually, the geochemist that we have on our team published these papers, but now he likes this value better, okay. And so this tells us that the parameters that we were using in trying to actually constrain the angular momentum of the Earth-Moon system needs adjustment. And so, again, back to Robin Canup, a new set of simulations. The way that you match that data if the aluminum is the same is not if you have a Mars-sized body that hits the Earth, but actually if you have one that's about the size of Earth, okay? So this is actually a fairly considerable change in our understanding of the formation of the moon. Okay, all right. So I said that most of the short wavelength gravity on the moon is associated with topography, and that means that only 1% of the signal that tells us about the mass variations in the shallow crust of the moon is from the subsurface. And so we wanted to see if there was anything there, we would find it. So, so what we did to try to sharpen up the short wavelength signals is just to take gradients. And if you take the gradients of those signals, what we found is that the moon has a gigantic set of massive dikes that nowhere intersect the surface, okay? So here's one. This is gravity, and this is topography in the same area. You look at any remote sensing data set, and you don't see these dikes coming up to the surface. So these dikes are between 5 and 20 kilometers wide, and they are on the order of 10 kilometers deep beneath the surface of the moon. They never got to the top, and here's an analogy of what they look on Earth. This is a shiprock, but this is a dike that was below the surface of the Earth, but erosion has taken place and has now revealed it. And so, so what was going on there is, we believe in the moon's early history, it was completely molten on the outside. It's something called the magma ocean, which was probably the biggest discovery that the Apollo astronauts made from the samples that were sent back. And so the moon has what we believe to be an inverted thermal profile. Usually in planets, the deep inside of the planet is hot and the outside is cold, but on the moon, the outside of the moon was molten and it heated up the inside of the moon, and then the moon expanded. Now we believe up to about 5 kilometers on the basis of models and the size of these dikes. And these dikes are essentially cracks on the moon that opened because of this heating event. So these are just some of the initial results that have come out of GRAIL. But I want to talk now about education on the mission, because the mission had an extremely important educational component. And as Bear noted, our education and outreach program was led by Sally Ride. This was, it was an experiment called MoonCam. And we put cameras, electronics, and 4 camera heads on each spacecraft. And these cameras had no scientific purpose, okay? Many times you have, well, science is always a good thing, so don't, you know, that's a, but, so you often have on a spacecraft a camera where they will let, you know, take some pictures for the general public or for students. But on this one, the cameras belong to the students. So if you wanted to take a picture using these cameras, you couldn't do it. You had to find some student who was enrolled in the program, and because it was their cameras. And we had over 200,000 students who were enrolled in this program. We had the students would download the software in their classroom. We targeted this for middle school areas. Sally was a big believer that middle school was the period of time where students had to decide whether they were going to take the hard math in high school that put them on the AP track so that they could study science or engineering in college. But we took everybody who applied, even as long as there was a responsible adult. So students at any level, Girl Scout troops, 4-H clubs, church groups, homeschooled kids, and actually it was the students who taught the parents and the teachers how to use the software. But all you had to do was have an adult who was keeping things on straight and narrow. And so we used this, and it was a very, very successful experiment. We also used the awareness built by this program to teach concepts of physics to students. And so one of the comments that we got when we wrote the proposal was, you want to do this program with students, but kids don't understand gravity, okay? And so my answer to that was, well, look at this chart here. You go into any classroom, and every kid in the class knows what's going to happen to Wile E. Coyote here, okay? And so, so you have a basis for beginning to teach gravity to young people. And in fact, we had a contest to name the 2 spacecraft. This is the 4th grade class in Emily Dickinson Middle School in Bozeman, Montana. The class named the 2 spacecraft Ebb and Flow. To join the contest, you had to write an essay about why you wanted to give the spacecraft the name. Sally and I judged the winners, and what these 4th graders said was, well, GRAIL is a spacecraft mission to study the moon's gravity, and we see the effect of the moon's gravity every day when we go out and look at the ebb and flow of the tides. So, they went one step further and said ebb and flow also describes the way the 2 spacecraft get tugged around in their orbit because of the gravity variations in the moon. So obviously, kids understand gravity, okay? Okay, here's a little video that was taken pretty late in the mission using the MoonCam cameras when the spacecraft were about at an altitude above the moon, comparable to the altitude that airplanes fly. above the Earth. So here the spacecraft was about 10 kilometers above the surface of the moon. And I should say, so this, well, it's a nice video. And I said at the beginning that these cameras had no scientific purpose, and we had to say that because if there was any scientific purpose associated with them, the scrutiny that would have gone into them would have priced us out of the ball game, and we would not have been able to do this experiment. So we said, okay, well, we're going to send these, but they don't actually have to work, okay? But we will do our very best. I was at the Lunar Planetary Science Conference in March, and there were indeed presentations based on analysis of MoonCam images. So, so they did wind up getting used for science anyway. So, and beautiful imagery. You can download these videos from the MoonCam website. Okay. All right. So, our goal was, because we wanted to map the moon at extremely high resolution, we had to go very low, and the moon's gravity field is extremely bumpy. So every week during our extended mission, we would do 3 maneuvers to circularize the orbits of the 2 spacecraft, and immediately within an orbit, those orbits would become elliptical. And we needed to expend fuel to then recircularize them. And so as a consequence of that, the mission could not last forever, but that's okay. But I said, I don't want a drop of fuel left over at the end of this mission. If there's any fuel left over, then we haven't gone low enough to do science, okay? So, Dave Lehman, thank you for humoring me in that regard. We decided to, we looked real hard. Our only constraint from NASA is that we could not crash the spacecraft at any historical site. And I really didn't want to do that, obviously, and none of us did. So we looked really hard, and we actually found a prominent, unnamed mountain in the near side of the moon at high latitude. This is about 77 north, and it was unnamed, so we named the sites after Sally. And okay. And this is my last chart. After the event, we found the crash sites. So these are just animated GIFs showing you the before and the after. And so both of the craters are 4 to 5 meters in diameter. This was taken by the Lunar Reconnaissance Orbiter camera. And discoveries were made by this impact because LRO changed its orbit to fly over just as the impact was occurring and sampled the plume and made the first detection of molecular hydrogen on the moon, as well as very high concentrations of other volatiles. So this is actually very interesting because we didn't expect to see. Volatiles have been detected at the lunar poles from the LCROSS mission. But this is an area that sees this considerable sunlight every month. And so the fact that there was that much hydrogen close to the surface, because these were very small impacts, indicates that the moon is a very interesting place for sequestering volatiles in a way that's just beginning to be studied using these data. So I will stop right now. And thank you for listening and for all of your interest and support in lunar exploration.
Something I find absolutely amazing. This is about women in space tonight, and this is a remarkable woman who's done some wonderful things in space. But also, she's a professor at MIT. Now, when I was choosing my university, I could not opt to even go to MIT or Caltech or Princeton or Harvard because they didn't accept women. or the military academy. See how things have changed in such a short time. And now you're a professor and department chair and all those wonderful things. I'd like to invite there are GRAIL team members here in the audience? Okay, whoever's associated with the GRAIL team, please come on up, and David Dressler will be presenting an award. And I'm going to bring this one back to Bear.
You might recognize this object.
Oh, all right.
Hold on, here's some more.
Oh, hey, guys.
Got the whole team here. All right.
Great, thank you.
We're off to early, Brian.
Okay, thank you.
Will you be able to take this back with you?
We'll see.
Yeah.
Let's allow 2 questions. We are running kind of late on time, so I see one there and one there. Let's get this one first and then that one. Yes. Oh, where's the mic?
This is the only mic we have left.
I'll repeat it. Ask it and I'll repeat it. Okay.
Well, I'm fascinated by your work, and I'm just curious, were there any anomalies from the far side of the moon versus the side that faces us because of all other influences, solar radiation, just the morphology? Did you find different distinctions that you didn't expect?
No, so the question was, did you find anomalies that were where the near side of the moon was different than the far side of the moon? So the solar radiation depends on the beta angle, which is the Earth's moon sun angle. So it depends where the spacecraft were so that's not near side, far side. The near side has the large lava-filled basins, which actually were known, and the far side has less of those. So one of the things we were looking for on the far side was evidence of an idea was put forward several years ago that the Earth might have not had one moon but 2 moons earlier on, and that it was the second moon was in a co-orbital, the same orbit as the main moon, and then hit it at a really low velocity and essentially stuck onto it to explain the highlands on the far side. And we were hoping to see evidence for that, but that did not transpire. We did not see that. So we have seen certain differences in detailed gravitational structure. And but where we do actually expect to see significant differences is in the mantle of the near side of the moon versus the mantle of the far side of the moon, because if you have all of that lava on the near side and you don't have it on the far side, it means something unusual was going on in the mantle on the 2 sides, and we are just starting to analyze that now. So ask me in another 6 months, and I'll have a better answer for you.
Okay. Yes.
Okay.
For the ebb and flow impact craters on the moon, elliptical or circular? And if they're elliptical, why are most impact craters in the solar system circular?
Okay, so the question was, are the ebb and flow's final resting places, are the craters elliptical or circular, and why are most craters circular as opposed to elliptical? Okay, so they are slightly elliptical, but the main reason for that is because they hit the moon at a strafing of an angle of 1.5 degrees, although they were on a steep slope, so they were slightly elliptical. But the reason that so impacts hit surfaces at all angles. But what happens is you're taking a whole lot of energy, and except for the huge ones, you're putting all of that energy into a point. And when and most of these impacts occur at greater than the sound speed, so they generate shock waves. They're hypervelocity, and the shock waves unless you're at degrees less than about 10%, the shock waves that propagate are hemispherical. So even a 20-degree impact generates a hemispheric shock wave, and that's why most craters on planets are circular. Okay.
Thank you.
Okay.
And I'm sorry we're not going to make time to ask more questions, but I'm hoping Dr. Zuber can stick around and.
I'll be around.
All right,
Okay.
cool. All right.
Okay.
I believe our next order of business has to do with chapter awards, right?
Yes, it does, but before that, I'd like some of the women of space that are in this room to please stand up. Dr. Mae Jemison. And we have a special guest this evening, Loretta Whitesides. Loretta's the originator of Yuri's Night. Thank you for coming, Loretta. All right, there will be a chapters assembly meeting at 10 p.m. this evening. So Larry, you got to get your awards done in a hurry. And also, we have a whole, thank you, Maria. Thank you.
He's Vice President of Chapters. Introduce Larry as Vice
Okay. Larry's the Vice President of Chapters. I have one more thing to add. We have a whole series of books pre-signed by Buzz Aldrin that if you wanted your book signed and you didn't get it signed yet, please see us tomorrow around noontime, and we'll be able to exchange your books with ones that are already signed. Okay, Larry, you ready?
Yes. Hi. Well, first of all, Dr. Jemison, Jerry Harris sends her congratulations from Chicago. I like to say one thing. This is we're talking about women in space. I don't know how many people realize that the first one in space was female. And unless you're an animal lover, you keep on forgetting about Laika. So females were first in space. Okay. Like he said, my name is Larry Ahern. I'm the Vice President of Chapters. Chapters, they're often an afterthought, like in the Academy Awards, we're more like the technical awards that people ignore. I like to start out by saying that last year I had a theme, and I'm going to carry that theme across again. All things are possible. Last year I left off with saying that a lowly receptionist went on to become Deputy Administrator Lori Garber of NASA. Being from Chicago, I'm going to use a little Chicago theme here. I remember a young schoolgirl who ended up soaring in a Chicago schoolgirl, my town, ended up soaring in space. So all things are possible, Dr. Mae Jemison. We are a nonprofit, and I remember a young, unknown nonprofit lawyer who, less than a generation later, has become our President of the United States, Barack Obama. All things are possible. And someone asked what this has to do with us in the movement. A number of years ago, we in activists, chapter activists, and then it's us, we use what little influence we have. And by a single vote, we have a space station, International Space Station up there. By a single vote, we saved the space station. Chapters are the engineers of the future. They educate officials, the public, schools, and themselves to a better future in space. So let us start with the awards. I'm going to have some help here. Would Bennett Rutledge come up here, please? Okay, Bennett. All right. Bennett's an old friend of mine. We go way back. He actually ran my campaign, my very first campaign when I ran for the board of directors. He is very innovative. I ran for the board. My name is Larry Ahern. I ran as a regional director. He had signs printed up. Larry Ahern, regional director. The L in Larry was in red. The R in the A in Ahern was in red. The R in regional was in red. And director, the D in director was in red. I was going around and was known as Lard. But anyways, I'm going to let you do the first one here, then I'll do the second, okay?
Okay. My first assignment is to present an award to a chapter that is very eclectic, very wide, has a wide variety of interests, and in particular has organized itself around supporting the publication of the Moon Miners Manifesto, which has been going for 26 years, exploring a wide variety of topics: art, chemistry, physics, geology, all some way or another touching upon living and working on the moon. The central figure of this effort has, for example, Yuri's night a year ago gave a presentation of what's next for space tourism and broadened that into a series covering not only the up and down for a few minute sort of tourist flight, but point-to-point trips soaring to distant Earth surface meccas, crude simple orbital factories, even more elaborate orbiting hotels and resorts. And this chapter also began planning to participate in the International Observing the Moon Night, and will be even more deeply involved in September of this year in that effort. And last but not least, they have a December pizza potluck, which I had the privilege of attending a little over a year ago, and it has some rather interesting food combinations. So, for extraordinary service, the Milwaukee Lunar Reclamation Society. Is David Dunlop here?
David? I don't think Dave is here tonight. We'll have to take care of that one. Our next, like they said, they want to move this along. Our next award is a chapter that consistently performs at a high level. They did 2 public lectures. They did outreach at 2 science fiction conventions, a picnic, a winter party, a local high school, and they also had a little thing called Following the Enterprise through Los Angeles to the Oasis. I'd like to present you with the Special Merit Award, Public Outreach. Would you please come up here? That Oasis. Bring them up. Let's go, let's go. As Dave says, we want to keep it rolling, keep it rolling. All right, I'll do the next one, then you. Okay. Our third award goes to a chapter that visited 4 schools, several museum trips, a science fiction convention, and much more. They have created space, what's the word, stuff, to illustrate their space concept. The award for excellence in education goes to the NSS Seattle chapter. Dave Stewart, get off your camera.
So this next chapter changed the format of its meetings in 2012 to have a brief business meeting followed by a longer series of feature presentations, such as what's happening in space each month, announcements from launch companies, videos of actual launches, and new discoveries in space, and sometimes a particular visit from a representative of an organization associated with space. Attendance at these presentations was usually 7 to 10 people, with a low of 5 in April because the normal meeting was postponed from its usual date by severe weather. Now, these people really understand severe weather because this is for the Oklahoma Space Alliance chapter. Claire McMurray here, please. Is Claire McMurray here? Ah, I see him.
Claire, I'd like to point out that Claire McMurray is probably our most successful regional organizer. Her chapters outperform most regions in the country. And I'd like to have her present the next award to a chapter in her region. Why'd you get up? By the way, I'd like to mention that Claire and I go way, way back. We used to filk right at night. Now, for you people who have dirty minds, filking is actually folk singing space in science fiction songs. It's not what you were thinking.
Well, Larry, you're going to have to help me because you didn't tell me which award they're getting.
Oh, you can't read it?
No.
Oh, that's right. You have excellence in public outreach.
Okay.
Yes, you want to help her.
This chapter does an amazing number of things. They put out a really pretty newsletter, which they're not selfish about. They'll send it to anybody.
Okay. All right.
It's called the North Texas Spacecraft.
For those of you that don't know, Claire had eye surgery a couple of weeks ago, and so she's forbidden by her doctor to read anything. Makes it rather difficult for her to be an MC. The one on the bottom, Larry?
Yeah.
Okay. Our fifth award goes to a chapter that did an outstanding job, an art contest, a poetry contest, a science fair. They worked with schools. They did various events in several interesting venues. Let's see. It's not my writing either.
I do know that they put on Moon Day, or at least cooperated in it. I'm not quite sure how the two organizations worked, and had pretty close to 1,000 people there, and a couple of chapters from other parts of the state.
Including our chapter from Oklahoma. So this award for excellence in public outreach goes to the North Texas chapter.
Ken Ruffin, are you here?
North Texas, I like to point out that the thing is, you guys could have done a reach for the top spot if you would have put down your attendance figures and your publicity. You did some great events, but we didn't know how many people you reached.
I can send you those numbers.
Okay.
So, next on my list is a chapter that meets one afternoon a month at a local public library to discuss such topics as cosmic collisions, black hole odyssey, John Glenn, Mercury and shuttle flights, magnetic storms, the life and death of a star, 7 wonders of the universe, Saturn, Lord of the Rings, Secrets of the Sun, Mars, the Red Planet, Space Dive, and Skywalking. I personally was there at a conversation that involved the multiverse and what might be going on if we had entirely new universes split off simply because an electron tumbled one way instead of another. They also produce a cable access program called Around Space on a local public access channel. And they started production on July 14th and have since produced a total of 107 shows, 7 of them in 2012 alone. So, July 14th, 2001. They also had an exhibit table at last ISDC. I'm sort of disappointed you didn't get to see it this time. It was a wonderful example of what ingenuity, creativity can accomplish with a cinder block, a styrofoam block, and a couple of other little things that ordinarily you'd expect to find in the trash. So, for extraordinary service, the DCL5 chapter. Joe, are you here?
Donnie and David, a married couple who, I think they're married, but they're the real engines of putting our chapter into this category. So I accept this on their behalf. Thank you.
It's a cool show. You should see it. They even have their own theme song. Only two more. Our next to final award goes to a chapter that practices overkill. Most chapters turn in their activities reports 2, 3, 4, 5 pages. These people periodically, I wouldn't say periodically, every year turn in 40-page reports in excruciating detail and in full color. These people perform at a high performance year in and year out, and they're always contenders for the top honor. And what he called, many people probably seen these people around here. Would Ronnie LaJolla and Johan Lowe come up here for excellence in public outreach?
Thank you.
Don't go far.
Oh, yeah.
Okay. Okay. Our final award is our Chapter of the Year award. This chapter, it doesn't sound special. They've done a science fiction convention. They did 2 or 3 other things, but they did almost 40 astronomy things. That's about 4 a month. What makes these things extraordinary, they reached over 7,000 people personally. This chapter normally doesn't perform at this level, and we have to recognize the extraordinary effort they did. I like to, the person that's charged of that, Chuck Schlimm from the Middle Tennessee Space Society, is not here tonight. Accepting on behalf of them is Johan Lowe.
Chuck is also a Health Off member. It's one of the health club, so thank you so much.
Okay, I'd like to end this by saying chapters are the life. I don't know if Dave has any announcements, but we're almost finished here. Chapters are the lifeblood of our society, the keepers of the dream of a spacefaring civilization, and they can all show us that things are always possible. Ad Astra, folks.
And Carol Mermel has asked to speak briefly, our Vice President of Development of NSS.
Just briefly, I wanted to say those envelopes that you found on your chairs as you walked in are a way of thanking Dave, of thanking the NSS for putting on conferences like this. If you give, that's great. We appreciate it. If you don't, keep the envelope for maybe when you're in a better space. But take it with you. Thank you.
And heed the spiritual messages of Rick Tumlinson when you're thinking about those envelopes. And we'll pass a plate around in a minute. I do have a few announcements. We're having an excellent party tomorrow night. We're going to have live music. We're going to have models. We're going to have games going on. All this stuff after 9 o'clock tomorrow night in the big room. And it's only $10. But buy your ticket today because tomorrow it goes up to $15.
And where can they buy their ticket?
You can buy your ticket online or you can buy it at the registration desk. But get it first thing tomorrow morning. We want to have that room packed with space people. It's going to be Star Trek stuff. Oh, we're having a raffle, too. Luisa managed to get basically a paid vacation in Puerto Rico. You still have to pay for the flight to get there, but once you're there, it's all free. And you get to raffle that off tomorrow. Also, Dennis Whipple asked me to inform you that he'll be selling DVDs of all the recorded sessions, and he'll be available for you in the exhibit hall after 10 a.m. tomorrow.
I have one more.
Yes? Oh, we have shirts for sale. Is this the new price or the old price?
No, it's $30. Available online. Cards are at the table.
These were 50 and now they're down to 30, so you want to grab these up as quick as you can. Isn't that beautiful? I think we have an artist in our midst. Thank you, Gary. All right. With that, we conclude our evening.
Wait.
Uno más.
Okay, yes, uno más. The next event in this room is tomorrow's lunch. I want you to be very, very nice to the speaker, Chris Ferguson, because he's my boss. So make sure he has a great experience here. And with that, I believe there's nothing else for this evening. Thank you so very much for attending our celebration of Women in Space. Thank you.